Hi and welcome to this video on solving differential equations. First of all, we need to define what a differential equation is. So a definition, a differential equation contains one or two or more terms, so one or more terms involving derivatives of one variable so that's independent variable y with respect to another variable. And that's usually an independent variable, x. So that's the definition. So let's have an example. So we could have dy by dx equals 2x. So we've got the derivative of one variable, which is y, with respect to another variable x, 2x. What we need to do when we're dealing with solving differential equations, we need to separate the two variables, that is, get all the x's onto one side and all the y's onto another side. And then we integrate and then we solve the equation. Let's have a look at some examples. For example, so we're going to have a look at this first example. Y squared dy plus x cubed dx equals 0. Now in this one the x and y terms are already separate but together on one side, so we can simply integrate. So we get integral of y squared dy plus integral of x cubed dx equals 0. So when we do this, we get, should be y squared, we get y increased by 1 divide plus x to the 4 over 4 equals constant. So y cubed equals 3k minus x to the power 4 over 4. So when we do that, we simply get the cube root x to the power 4 over 4. And that's our answer. Okay, let's have a look at solving differential equations by separating the variable. So if we have dy over dx equals 10x minus 1 over 4 plus 3y squared. So separating the variable, we bring the x's to one side and all the y's to the other side. So here's a y, let's bring it to the other side, so this becomes 4 plus 3y squared, and bring the dx to this side, leaving the dy here, so dy, and this then becomes 10x minus 1 dx. Now let's integrate on both sides, so we get integrate 4 plus 3y squared dy, and then integrate the other side, 10x minus 1 dx. Here we get, when we integrate this side, we get 4y plus y cubed plus a constant, and on this side we get 5x squared minus x plus a constant. Now C1 and C2 are constants, and C2 minus C1 is also a constant, so really we could just have one constant by itself. So this then becomes, on rearranging, 5x squared minus y to the power 3 equals 4y plus x minus c, where minus c is a constant. This is 5x squared minus y to the power 3 equals 4y plus x plus a, where a is a constant, and this is called a general solution. Let's move this up a little bit. Now if we were given x equals 1 and y equals 0, then we could put these into our general solution. So we get 5 1 squared minus 0 to the power 3 equals 4 0 plus 1 plus a, and solving we get a equals 4. So we would put the 4 in there, and that would give us our particular solution. If we want to check that we've solved the differential equation correctly, we can always double check. So we get our 5x squared minus y cubed equals 4y plus x plus 4, and we differentiate implicitly with respect to x. So what we get is 10x minus 3y squared dy by dx, because we're differentiating implicitly, minus 4 dy by dx plus 1 plus the constant becomes 0. So 10x minus 1 equals, bringing these dy's onto the other side, 4 plus 3y squared dy dx, and then therefore dy by dx equals 10x minus 1 all over 4 plus 3y squared. And that was the differential equation we started off with. X plus 2 dy by dx, x squared plus 4x plus 9. So what do we do here? So this then becomes, on rearranging, x plus 2 dy equals x squared plus 4x plus 9 dx. Now if we move all the x's to one side, separate the variables, we get dy is x squared plus 4x plus 9 all over x plus 2 dx. Now we can do some algebraic division here, so let's do x plus 2 x squared plus 4x plus 9. So we'll get x here. X times that is x squared plus 2x. Subtract, we get 0 plus 2x, bring the 9 down, so we get plus 9. Here we get 2x plus 2x plus 4, subtract, we get 5. So the remainder is 5 over x plus 2. So this then becomes, on simplification, dy equals x plus 2 plus the remainder, which was 5x plus 2. Integrating on both sides, we get integral of dy equals the integral of all of this, which is x plus 2 plus 5x plus 2. So this becomes y equals x 2 over 2 plus 2x when we integrate the 2 plus 5, and this is a natural logarithm, so it's natural log x plus 2, and don't forget the plus constant. dy dx is sine cubed x cos squared x plus x e to the x. So moving the dx to the other side, we get dy equals sine cubed x cos squared x plus x e to the x dx. Integrating on both sides, we get integral of dy equals integral of sine cubed x cos squared x plus x e to the x dx. Now, because we've got this plus sign here, we can integrate this separately. So this will become the integral of x e to the x. And then we can integrate this separately. So let's do this integration first. So if we have the integral of this, it's integral of sine square, so we can split the sine. Here we can split the sine cubed into sine and sine squared, so we have sine squared x cos squared x sine x dx. Now the sine squared x, let's do some substitution. So let cos x equal t, and then minus sine x dx equals dt. So this sine squared x becomes, sine squared x is 1 minus cos squared x. So this becomes the integral of minus 1 minus t squared dt. And if we get rid of the brackets, that becomes the integral of t squared minus t4 dt. When we do the integration, this becomes minus t3 over 3 plus t5 over 5 plus a constant. So when we replace the t's from our substitution here, we get minus cos cubed x over 3 plus cos to the power 5 x over 5 plus 0. Now we're left with this integral here. So the integral of x e to the x dx, this becomes x e to the x minus e to the x plus c2. So when we combine, we get minus cos cubed x over 3 plus cos to the power 5x over 5 plus x e to the x minus e to the x plus a. We want to solve the differential equation 2 dy dx equals yx plus 1 all over x. So we take the x dx onto the other side and bring the y over here, so this then becomes 2 dy over y equals x plus 1 over x dx. Let's make this into something we can differentiate, integrate rather. So this becomes 2 dy over y equals 1 plus 1 over x dx. Now let's integrate on both sides. So this is the integral of 2 dy over y equals the integral of 1 plus 1 over x dx. This is 2 natural log of y equals x, 1 becomes the x, plus 1 over x is natural log of x, plus a constant. So the natural log of y is x plus natural log of x plus k all over 2. Then when we exponentialize, we get y equals e to the x plus natural log of x plus k over 2. And that is our answer. Equation dy dx minus 2xy equals x. Now a technique to solve this is to use what's called an integrating factor, or an integration factor. And this is simply, we get the minus 2x, which is here, and we get e to the integral of minus 2x as the integration factor, and that is e to the minus x squared. So that's our factor. So then we multiply both sides by this factor. So we get e to the minus x squared dy dx minus 2e minus x squared y equals e to the minus x squared x dx. Now what this does is, this is a function and a derivative, and we can just reduce this down to d by dx e to the minus x squared y equals the integral of x e to the minus x squared dx. So we simply need to do this integral now. So this is half integral of, we do some substitution, this becomes e to the u, where u is minus x squared. So e to the minus, bring this down, equals a half e to the minus x squared plus c. So y e to the minus x squared is half e to the minus x squared plus c, and that is our answer. Okay, if we have another similar differential equation, dy dx plus 3y equals e to the minus x, we want to find an integrating factor that when we multiply both sides by, on the left hand side, will give us the function and a derivative. So if we multiply by the integrating factor of e to the power of 3x, this gives us e to the 3x dy dx plus 3 e to the 3x y, and then over on this side we get e to the 2x. So this here is the function and a derivative of y e to the 3x. So this then becomes dy over dx y e to the 3x equals e to the 2x. Then we integrate both sides. We get y e to the 3x equals a half e to the 2x plus c. So y equals a half e to the minus x plus c e to the minus 3x. Okay, let's look at another differential equation where we're able to separate the variables. So we have dy by dx is equal to 3x squared 1 plus y squared. So moving the dx to the other side and the 1 plus y to this side, we get dy over 1 plus y squared equals 3x squared dx. Integrating on both sides, get integral of dy 1 plus y squared equals 3x squared dx. On this left hand side we need to do some u substitution, so if we let u equal y, du equals dy. So this then becomes the integral of du over 1 plus u squared equals integral of 3x squared dx. This is just 1 over a, where a equals 1, tan inverse u over a plus c. So this, when we do the integration, becomes 1 over 1 inverse tan or arctan y over 1, and then when we integrate here we get 3 x to the power 3, and then bring 3 down over 3 plus c. So arctan y equals x to the power 3 plus c. So y equals tan x3 plus a constant. X squared plus 1 dy dx equals xy. So what do we do here? We can get rid of the x plus 1 by dividing through by x plus 1. So this x squared plus 1 divided by x plus 1 just leaves us with dy by dx equals, here we got x squared plus 1 on the bottom, and we've got x and y on the top. So let's bring the y's to one side and leave the x's on the other side. So this becomes 1 over y dy equals, and then we're just left with the x on this side over the x squared plus 1. Now let's integrate on both sides. So that's the integral of 1 over y dy equals the integral of x squared plus 1 dx. Should go dx over here. So when we integrate on this side, we get the natural log of y equals a half integral of, if we do some u substitution, if we let u equals x squared plus 1 du equals 2x dx. So half du equals x du. So this then becomes 1 over u. So the natural log of y is half natural log, and when we replace the u, that becomes x squared plus 1 plus c. So the natural log of y, y equals, when we exponentialize e to the half natural log x squared plus 1 plus c. Now this half can be brought over here, and then the e and the natural log cancel each other out. So y equals square root of x squared plus 1 multiplied by e to the c, where that e to the c is a constant.